Module 3, Lesson 5, Confidence Intervals for Means. This lesson is not that much different from your last lesson, where we learned confidence intervals for proportions. The only difference in this lesson is that we're focusing on a different parameter, means. Let's start with an example. A university wanted to get an idea of how much students were spending on textbooks each semester. A questionnaire of spending habits was given to a random sample of students. Each student was asked to record the amount of money they spent on textbooks in the prior semester. The sample of 40 students resulted in a sample mean of $422 with a sample standard deviation of 57. Much like our prior lesson, we know that this value, 422, is a point estimate. And if the university had asked a different set of 40 students, the sample mean would probably be a little different. Could be higher, could be lower. So we know that there is still sampling variability when we look at sample means. Because of that, we want to create an interval of values or a range of values instead of giving a point estimate. The assumptions we need to make in order to do this is that our sample was a simple random sample, and in our case it was. Also, we want to be able to assume the population is normally distributed, or we have more than 30 in our sample. We're not sure if our population is normally distributed, but we certainly do have more than 30 in our sample. Our sample contained 40. The trouble we have for this lesson is that we cannot use the normal distribution to create our interval. And that's because we don't know the population standard deviation, similar to the techniques we learned prior in this module. This is often the case when you're trying to estimate a population mean. If you don't know the population mean, odds are you don't know the population standard deviation either. This brings us to a new distribution. It is called the student t-distribution. The student t-distribution is used when sigma is not known or when you have small samples. The student t-distribution isn't that much different than our normal distribution. Our normal distribution is in the bright blue color right here. A student t-distribution is also symmetric and bell-shaped. It's just that it's a lot shorter, thus wider on the edges than your normal distribution. Another unfortunate thing is that the student t-distribution will change size, height, or width depending on how many you have in your sample, which means that our critical values that we'll use in creating the interval are going to be a moving target. They're not going to stay the same as they do with a normal distribution. Let me show you what I mean. The confidence interval for a mean is given by this formula in red. Our point estimate plus or minus t star times s divided by the square root of n. T star this time, not z star. Now our critical value t star will be from the t-distribution, and it's going to depend on a particular confidence level and also on the number of degrees of freedom. Now we can get our degrees of freedom by taking 1 away from n, or we like to say n minus 1. What does little n stand for? Sample size, that's right. So it's 1 less than our sample size. So in our table called the t-table, notice we're not using the z-table anymore. This is table A3, and it's the t-distribution, or critical values, as I call them, t star. The first column are your degrees of freedom. And you can see the degrees of freedom, I have them here up until about 40, and then they start skipping a little bit. But 1, 2, 3, 4, all the way up, every value up until 40. So these are our degrees of freedom, n minus 1. And here, across the top, we'll be able to determine, depending on what kind of confidence we want, which one of these columns do we want to use. For instance, if you were doing a 99% confidence interval, you would have 1% in the two tails. So we would use this first column. If If we were doing a 95% confidence interval, we would have 5% or 0.05 in two tails, and we would use the middle column. Back to the question about how much students spend on textbooks. Let's tackle this by computing a 95% confidence interval for the mean amount that they spent on textbooks. Recall from the beginning of the lesson that we had 40 students that spent a mean of $422 and a sample standard deviation of 57. The degrees of freedom we'll be using for this problem is n minus 1, in our case 40 minus 1, which is 39. So if we take a look at the first column, you can see that 39 is down here towards the bottom, 39 degrees of freedom. That tells us which row we'll use. And again, we want a 95% confidence interval, which leaves 0.05 in the tails. So if we cross this middle column with this row down here, you'll see that we'll arrive at the number 2.023. This is going to be our critical value. Notice it's a little larger than the critical value if we were using the z-distribution. For a 95% confidence interval, that is 1.96 we've learned. But with a t-distribution, they tend to give a little larger critical values. Thus, it's going to make our interval a little bit wider than a z-distribution would. Okay, let's use this formula. We saw it earlier. The sample mean plus or minus our critical value from the t-distribution times the sample standard deviation divided by the square root of n. These are all the things we know thus far in the problem. The first three were given, and we found the t star in our table. Take a moment and plug these values into the formula above. You can see all four values have a place to be plugged in. If we simplify the stuff on the right hand side of the plus or minus, our next step would look like this. 422 plus or minus 18.23. What this 18.23 is, I should say, is $18.23. This is our margin of error. We're going to take the $18.23 and proceed to add and subtract it to our sample mean of $422. Here it is when we subtract, which leaves us with $403.77. And here's the add. $422 plus the $18.23 leaves us with $440.23. Put these together and we have a confidence interval. And we'll be able to state that we are 95% confident that the mean amount that students spend in one semester for textbooks is between $403.77 and $440.23.